Hi team, welcome to the backyard edition of Living Environment. It's a beautiful day. Hope you've gotten a little sunshine today. If I usually do some like funny GIF here, but I was thinking it'd be nice to just, everybody give yourself a hug. You're wonderful and we love you. Okay, so let's go over the plan. We have already done this day, right, where we looked at the different structures of the virus and tried to figure out what their jobs were. And today we're going to do a review of that material, and we're actually going to assess what we put together at the end of the day. And then just bearing in mind as we go forward for the next 2 weeks, our next assessment is going to be 2 weeks from today. So let's get started today. Basically, here is what we're going to do. We're not going to do that. We're going to do this. Okay. So today we're going to review the viral structures that you put into your work on Tuesday. And I'm going to stop a few times and actually let you revise based on what I say in the presentation. To that end, I suggest that everybody do the ed puzzle because you'll get a chance to review your work as we're going. Of course, like live lessons are still available, and I really hope that you come to them. Especially if you aren't sure how to get started with your viral infection for dummies. But like try to go and revise your work using the ed puzzle first. If you're totally lost, absolutely come to live lessons and office hours, which I'll talk about again at the end. Okay, so the very first structure that we needed to look at was one viral particle, and just about everybody got this one. This is my virus particle. Now, if I cut it open and I look inside, I have 3 really important structures, and all of these were somewhere in that organizer. So let's make sure we got them correct. What's my red guy that's sticking out like this? This is my antigen or my protein spike. How about my yellowy orange items that go around the outside? This is my lipid layer, right? This is the protection around the outside of my virus. And then there's something inside that's extremely important, so important that we're going to protect it with a layer of fat, and that is called my viral RNA. So this is my genetic material, right? And it's very, very important, which is why it's so protected. Okay. So before we go into the function of all of these things, if you want to stop and go ahead and make a adjustment to anything that you've done so far, you can go ahead and take a second to revise. Okay? All right. So this picture I think was really, really important. Some people included it, some people did not. There was some confusion around a few things. So we have our viral particle, and then I want to talk about the difference between this blue area and this gray area. So the blue area is outside of a cell. It is like in your airways or in your lungs, maybe it's in your nose. It's just in the air that you breathe into your body. This gray area is the actual cell. Okay, so to be inside a cell would be to be in this gray area, and that's like your lungs. It could be a cell in your lungs, it could be a cell in your throat. So these 2 structures are going to work together for a very specific function that's going to be extremely important, because right now there's no way for this virus to get into the cell. This membrane that goes along the bottom here, this is my cell membrane, and remember, its job is to protect my cell. So you can think of so let's just make sure we get some names here. My red spike again is called my antigen. And can you guys remember what this gray sort of wrench-like looking thing sticking out is called? So that's my receptor. That's my cell receptor. And in my metaphor I'm going to talk about right now, you're going to think of the receptor as like the lock. And I want you to think of the antigen like a key. So if we look at this, the job of the cell receptor, right, is like this lock. It's meant to stay shut unless you have the correct key. So the cell receptor is like the lock and the antigen is like the key. And if the antigen matches the cell receptor, then the cell receptor is going to open up or the cell membrane is going to open up and let the virus in. So as long as my virus is out here in my airway, then it's not doing me any damage. If it actually gets inside of a cell, if it can open up the lock from a receptor, then that's when it's going to start doing damage. So pause here if you weren't sure about the function. Pause here if you weren't sure about the function of a cell receptor or an antigen was. Go ahead and revise that. All right. Now, one time before we move on, I want to review this genetic expression just once more. So in a healthy cell with no virus in it, what happens? We have our DNA, and a protein is going to unzip my DNA and make a copy, which is going to become RNA. My RNA is going to leave the cell. Right here we see it leaving the cell. And now this ribosome is this green thing. It's actually going along the RNA. It's reading the RNA and it's building a protein chain. So in this healthy cell, that protein chain could be insulin, could be an enzyme, it could be the protein that goes and unzips the DNA, it could be anything. There's a whole bunch of different things that it could be. Whatever it is, though, it's doing a job that your cell wants it to do. So this is sort of the healthy way this goes. Now we want to think about what happens when instead we have a virus actually invading our cell. All right, so let's go back to where we were. The virus has just been let into my cell. And once it gets let into my cell, it's going to release the DNA, the viral RNA that was inside. So all of this beautiful gray squiggly RNA is getting let into my cell. Remember, this gray area in the background is always my cell. All right. So you've probably seen this picture. I have my viral RNA, this red line, and this thing is building a viral protein. So what is this thing called? What is the part of our cell that reads RNA and builds proteins? Okay, this is the ribosome. So I think a lot of people weren't sure about this one. This guy, this like kind of greenish, grayish item is my ribosome. So if you need to go fix that in your pictures, I want you to go do that now. If you have a picture of viral RNA that looks like this, that's fine. You can use that one. Now the job of the ribosome is to build proteins. Now remember, if it's reading my RNA, it's going to build a helpful protein. But what's going to happen if it's reading viral RNA? Well, let's see. If the virus comes in and releases its RNA, then this RNA is no longer my RNA. Now it's going to read viral RNA. And the ribosome is going to go ahead along building a protein chain, but now instead of being a protein chain that I want, it's going to end up being a viral protein chain. So again, the ribosome is reading my viral RNA and it's building a viral protein. Okay, so this part I didn't ask you to look at, but here you might have noticed there's viral proteins in the article. So what is the point of these viral proteins? Well, if I look at my structure of my whole virus, I can see the different parts, right? So this red protein that my ribosome built is going to become a spike protein. These yellow items here are going to become my lipids and protein layer around the outside. And my RNA is going to go ahead and be the RNA. So my cell, the ribosomes in my cells, just instead of building things like insulin, now it's building parts of a protein, or I'm sorry, parts of a virus. So all these parts are going to come right together to assemble a new copy of a virus. And then your cell is just going to move those newly copied viruses and release them back into your airway, where this whole process can start all over again. Eventually, your cell is going to just explode from making so many viruses and die. So goodbye, cell. You're dead. So let's talk about this really, really generally. What was the goal of the virus? Its job was to replicate as many times as possible. The virus's goal is not to get you sick. The virus's goal, what it is trying to do, is to make copies of itself. How does it do that? It takes over a healthy cell by releasing a set of instructions, the RNA, that are different from your cell's RNA. So the new instructions, this viral RNA, is turning your cell into a factory that builds new viruses. While that cell, your infected cell, is busy building a new virus, they're not doing their normal job, and that's why you feel sick. Okay, because your cells are always doing a job to help you breathe, to help you digest, to help regulate your blood sugar. Your cells are always doing a job. Because the cell is now busy making more viruses, it's not doing its job, and that is why you feel sick. Okay, so we did these two really important jobs. I just want to talk about what I expect you to do on your assignment today, and then I'm going to let you go. All right. So today's assignment is called Viral Infections for Dummies. Your job is to use your understanding of the viral structures to create a step-by-step guide for understanding viral infections. This is due on Saturday at midnight, so I would just try and do it right now. Imagine you are a virus, it's your first day on the job, and you need to start infecting some cells. Create a step-by-step guide to teach a virus how to infect a host and reproduce. And by host, I just mean a cell that is not a virus. Okay? So when I say for dummies is a type of guide or a how-to book that has like step-by-step instructions, and they make them really clear. So there are a bunch of them. There are like so many of them. This one is writing fiction or using a computer, cooking, or there's even like flirting for dummies. So when we say you're making a viral infection for dummies, you're just explaining the step-by-step. So I gave you guys an example. This would be my how to plant an oak tree for dummies. So if I wanted to plant a tree, this is how I would do it in my step-by-step. So first, I'm going to find an empty place in my yard, and I'm going to use a picture to illustrate what I'm doing. Then I'm going to dig a small hole, and again, I'm going to show a picture that illustrates my caption or my step. All right, here's my hole. Next step 3, put an acorn in the hole and cover it with dirt. So here's my acorn, and I cover it up with dirt. Then the next step is to water the acorn. So that's this. Now I'm going to wait 50 years until I'm old, like Dumbledore. Just waiting. And then my last step is to enjoy my tree. Okay, so these are my step-by-step instructions for how to plant an oak tree. And you are going to do something similar. So you can kind of use this as a model. So I just want to make sure you guys know sort of what we expect. So your instruction should begin with the virus entering the body. So you're going to have to show me how it gets from like an airway to an actual cell. So make sure you include that. And it needs to end with the newly created viruses being released by the cell. You need to include these words: antigen, genetic material. You can also use RNA. You need to include lipid layer, receptor, and ribosome. And your explanation should include at least 4 steps, and it could probably use up to like 6. Okay. I want to let you know how we're going to grade, just so there's no confusion. So if you don't do it, you'll get a 0. If your work is incomplete, or you are totally confused, that will be a 1. So obviously, if you're feeling confused, please come to office hours and live lesson. Step 2, or layer 2, if your work qualifies for 2, it would be that you have some accurate structures, but you aren't sure what the end result of the infection is. Here's an important point. If your captions are not in your own words, the highest you can get is a 2, even if everything is perfect. So if that happens, if you copy and paste some captions, we'll send it back to you as a 2, and you'll have the option to resubmit it. 3, so a student who gets a 3 clearly understands the functions of the different viral structures and understands the final step, or like what the goal of the virus is. And then to go from like a 3 to a 4 would mean that your instructions are really, really clear. Your pictures match your instructions, and your steps are in order. So today, during live lessons, we're going to review the material from this video and get started on the assignment. So please attend on time. We're going to start at 1:20, and we're not going to have time to like go back to the beginning. So please make sure you get there on time. Office hours today are at 1:50, so just after live lessons. I did say that we'd have an option for revising work. So Mr. Chervin graded your work from Friday, so he'll run a revising that session. And my session will be about help on today's assignments. Miss Tara's session will be run in Spanish. And if you want to know more about hers, you can check in with her. All right, guys, those are all my instructions. I know it's a lot. Thank you so much, and hopefully we'll see you at live lessons. Bye-bye.